Okay, this is a lecture on hash tables. Um, those of you who are familiar with array lists and feel comfortable with them will find that hash tables just add another layer to the array list, which makes it actually easier to use. Let's start off with an array list. Now, array list and a hash table are very similar. Um, Here's an example. Let's create an array list, control spacebar, and we want to store integers. We'll call it nums. New array, control spacebar, enter. Okay, at this time I am able to add data to my array list. So I can say nums.add. Now I can add an integer. We'll say 50. Nums.add, not at all. We'll say 20. So we're out of order right now. And nums.add 30. So as you can see, I'm putting them out of order. And there's a reason for this. The first thing is that you'll see that when we print this out, so sys out nums, when I print out nums, it will print it out in the order that we created. So 50, 20, 30. So first in, first out. The reason I bring that up is because when we move to hash tables, you lose that sorting and or the way that you put it in, and there's a good reason for that as well. So I'll explain that as we get into this. All right, so suppose we had a list of numbers that stretched for, and they could be random numbers, 100 million. 100 million records are stored in here. And we want to find one particular record. Now, in this case, it's a little harder because they're integers, so you know there will be a lot of duplications, or they can be. An integer can store up to plus or minus 2 billion, so we still are fine. But suppose we have a list, 100 million records that are all unique. All right, so now we want to find a particular number. Let's say we want to find if there's 9 million. I want to know, does the list have the number 9 million? Okay. So how do we do that? In an array list, there's really only one way to do it, and that is to do this. Now, of course, you can have a different way that you iterate through the array, but if we do something like this for in I in nums, if I is equal to 9, then we'll do two things. We will sys out, yes, I found it. And then we want to at least do one thing more, is break. We want to break out of the loop. And I don't typically do the curlies if there's only one thing, and as you can see, there's only one thing here. But I'll put them there just so you can see what we're breaking out of. So I'm breaking out of this for loop once we find the number 9 million. If I don't find the 9 million, well, there's really nothing to say here. I can't do an else. Okay. If I say else, it would look at the first item, and if it's not found, then it would just say else. No, I didn't find it. So we can't really have an else in here. What we might want to do is say sysout searching, and then yes, found it, and then sysout search completed. All right, so there we have it. We have we know that obviously 9 million is not in this list. We're going to loop through the list though, looking for 9 million. Now this one only has to loop 3 times because we only have 3 numbers. But if I had 100 million numbers, then I would actually, and none of them were 9 million, I would actually have to loop 100 million times. We can see that by doing this. Int count is equal to 0. And every time I'm in here, I'll say count plus plus. So I'm adding 1. And then when we print out, we'll print out the count. Okay, so let's run this and see what we get. Searching, search completed, 3 items checked. Now that makes sense because I have 3 items here. So we were not able to, we did not find it, but we were checking every single number. So what happens if I put in a number that I am looking for, that's actually in the list? We'll say 20. So it's going to say, yes, we found it. And then this is going to say search completed, and then it's going to give us our count. Our count's going to be 1, 2, rather than the 3. Let's go ahead and check that. So in this case, we did see that we only had to search twice. This is what we call a linear search. We are searching through a list to find an item. And we start from the start of the list, and we work our way to the end of the list. Although we could start at the end of the list and work our way to the start of the list if we wanted. We still come across the same problem. The problem is that we have as many items in the list is our worst case scenario. So we would have 100 million checks had this been the issue. Okay, so maybe we can even do that. Let's take a loop for int I is equal to 0. This is going to take a while. I is less than 100. I plus plus. And then we need a random number. So let's create a random generator here. Random. RND is equal to new random. And we'll put a number, we'll put some numbers in here. Now remember, the 100 million records are going to be added. So we're going to say RND dot next in, and we'll put a bounds of 100 million. Okay, so this is going to take a while. I believe it's going to take a while to just create 100 million integers, put them into the array list. Then we're going to, we don't want to print our nums, that is for sure. We can say we're start searching. If I found it, it'll tell me how many. And we're looking for now the 9 million. So 9. Okay. So let's clean this up a little bit. want to print out the numbers. That was only for the purpose of seeing how things work. But here's a good example. So we're looking for 9 million in this 100 million. Okay. All right, I'm going to run it. It's taking its time. It's 100 million loops. And it's be 100 million checks afterwards. Now this is going to run a lot faster than this. I'm generating 100 million records here, and I have no idea even what we're up to. We should have probably put a little timer, and if I could pause the video, I would. Actually, maybe I will. Okay, well, here's the problem. We ran out of stack space, so that was a little bit too big. Let's cut it down to maybe 10,000. Okay, that's going to run a lot faster. And then, of course, we're going to have to look for if the biggest number is, well, actually, the biggest number could be anything. You know, there you go, 1, 2, 3, 1, 2, 3. There's a million. So let me look for 900,000. Out of that million. We'll try it again. All right, here we go. Run it. Hopefully 10,000 isn't so bad. It's not. And we found that although this had 10,000 with a possible million, a number from 0 to almost a million. Okay, so from 1 to a million, we look for 900,000. So we'll try it again. No. We can try it a couple more times, and we're just not getting it. So out of 10,000 numbers, we're finding that we're not finding that 9 million. Okay, now here's the problem. Now we had to make the list a little shorter so it ran faster, but the point is that I had to loop through every single one. So my count became 1,000, okay, or 10,000. Let's try 100,000. Let's see if I can squeeze that into our stack. Okay, we are. How about a million? Okay, not too bad. 10 million. Okay, now that might crash our system. 10 million. Oh, it was found. All right, so here's a great example. We were looking for 9 million. It was found at item 14,523. Okay, so everything I've talked about has to do with this linear searching of a number, and that becomes a problem. Okay, there's really no need when you are running an example like this to have to use or go through in a list in a linear fashion. Now, if this list was sorted, then I could take and do a binary search, which means cutting it in half. It's like asking someone to guess a number from 1 to 1,000. The first number they should pick is not 1, but should be 500. So you split it in the middle. And you would say, no, it's higher than that. So then they've already cut off 500 numbers they don't have to check. This is called a binary search, and we'll go over it in more detail later in the semester. But here's the problem that we had here. In this case, we were using an array list of integers. So let's change this up a bit. Let's kind of do the same thing, but instead of using an array list, okay, let's use a hash table. Okay, so actually let me comment that out. We're going to use a hash table. I usually use a hash map, excuse me. I usually use a concurrent hash map, and we'll talk about that also in class. But a hash map is very good. It's the same thing. So Control space bar, and now we see that hash map has this K and this V, where in an array list, it has an E. Now, they're basically the same thing. So this E is like the V up here. It's the value. They're equivalent. So the array list stores some value. A hash map stores a value. Okay. So let me show it to you like this. The hash map stores a value. What are we going to be storing? Well, same thing we stored up here as an integer. We're going to store an integer. The thing about a hash map is, for every integer I put in there, I can put in a key to it, which means just like a unique ID, the key for that integer. Okay, so let's suppose I am doing something like this. I would put probably, let's put a string for the key, and I'll show you what that means. So I'm going to do the hash map. It's a string. There's an integer, and we're going to call it nums2 is equal to a new hash map. And there we go. Now I'm going to get rid of this example here, or I'll highlight it and comment it out so that we can work just with this one. Okay, let's move that down here. And then we'll work with the hash map. All right, so let's take a quick example. So I have this nums2, or that we're going to put some integers in. So, well, the way we put numbers into this list is not to dot add, but to dot put. You can see it wants to put. You give me a string as the key, and you give me the value. So I'm going to say n 55, n-55, number 55. And the value, we're going to put 55. Now, we don't have to do it this way. Typically, this is going to be a string, and then this is going to be an object like student. And what we would use for their string is the student's ID or something. Let's move along. nums2.put n-2, we'll put in the value 2. Okay. In fact, let me make this, not that it matters, but we're going to say 0, 2. And then nums2.put, and we'll put in n-0, 3. And of course, we're going to put in 3. Okay. So as you can see, the numbers 55, 2, and 3. Well, 55 should be down lower than 3. Okay. But other than that, like if I did, suppose I did this, this seems like, hey, they're in order. Okay. But if I keep it up here and we print out, we print out our nums to dot values, we just want to print those out. You're going to see that the order that we put them in has changed. Run it. We have 3, then 2, and then 55. Okay. If we put in, how about this? Let's put this. Let's say this is let's say this is B, A, C, and this is A. Run it again. Now we see 3, 55, and 2. And so if you notice, if I put that up there, 355 2, it's in order of the key. Remember we talked about uh, the binary search. So when I'm looking for a value in my list, I could actually look for it by the key. So what does that mean? Well, I can do this. I can say system.out.println nums2.get, and then it wants the key. So I want C as my key. I want to find C. The value comes out as 2. It's right there. Now, if you think about this in terms of a huge list, like the one we'd have down here, then what happens is the list is sorted as you're adding numbers in, and the searching becomes a binary search. So let's go ahead and try that out. A bigger example. So nums2 dot put, and here's the same example, some random number there. Okay. So here we go. We are going to have to change this around just a little bit. We're going to say int num is equal to this random number, because what I want to do is put num as the value, but I want to say something like num dash plus num as the key. So this is the key, and this is the number. Let's take this down to 10 for right now. Okay. And let's print out the list. So sysout nums2.values. And let's just see what happens. So what I'm doing here is I'm putting into this nums2, which is a hash table, a key of num dash whatever the number is, and then the value num. That's the same as the array list. We're just storing the number. But along with that, I can give it some unique data. Now, it is possible that I might come up with the exact same random number. And in that case, it just will override the last one. So let's go ahead and run this. Okay, so here are our numbers. These are the random numbers. And if I want the same list of random numbers to test this, let's say we just put in a number up here in the random. Okay, so I just put 10 up there. So everybody will have the same list. Every time I run this, I'm going to get the same list of numbers. Let's see what that list will look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 unique numbers. And so I know the value for this is 378,982. And then the unique ID for this, to search for this, would be num dash, the same thing. So let's take this guy right here. And so I want to search for num2 dash and then that number. And I want to, hopefully I'll get that number to pop up. I should. Run it. And we did not. Of course, you know why we didn't, because I used nums2 here. It's not nums2, it's num dash this. So let's go ahead and run it. And there we have it. So you can see where if this was in a list of numbers here, let's say back to its original, Okay, and I'm going to look for this. It's going to come up fairly quickly. So I don't want to print out 1,000,000 of those. I'm going to run it. And if we had a timer on this, we could time how quick this would be. So this takes the longest amount of time. This is actually immediate. So if we set sys out start, and then we'll see the time sys out start looping start searching. We'll see that this takes a long time, but as soon as this gets done and as soon as this prints, this should print out immediately. That's how fast it is. Run it. The next two should come up exactly at the same time because it was so quick. If you were looking for that 9,000,000, I don't know what it is. I don't know if it'll be found or not, but let's try it. So that's the long part, and no, it did not find this as a value. Okay. So that is the introduction to hash maps. They're very easy. This is an example with numbers, but we can easily do this with strings and objects, which we're going to be doing in the next lesson.